Hello guys and welcome at my channel. Today we'd like to start producing a sine curve and combining few basic values of the sine curve like sine of 30, sine of 45 and well maybe sine of 60 as well. Alright, so in the last video we've done the introduction and now we just go a bit deeper. So this is a unit circle once again that we've been working with. And if we're talking about the x or the y value, so if we're talking about this point, this is 90 degree, this is x, and this is y. You remember x is the cosine of phi and y is the sine of phi. And well, we also figured out that the values are between -1 and 1, so everything is fine. Now let's start with the sine curve. If we start, if we want to like have the basic graph from 0 to 360. So this is going to be 180, this is going to be 90, and this is going to be 270. So what can we do here? Well, we know for sure at 0, if this angle is 0 degrees, so we're just lying here, the y value is 0 as well. At 90, we're at 1. At 180, we are at 0. We're talking about the y values, as you can see. At 270, we're at -1, and at 360, we're coming back to 0. So now we have all kinds of possibilities how the sine curve actually could look like, okay? We don't know exactly it's a wave, okay? Maybe you've seen the picture or you know it because you've been working with that for many years, but the question is, it could be looking like this as well. We just do not know, okay? We have to prove it. We have to figure it out. What we see here clearly is if we're running between 0 and 90, that would be exactly the same shape what we should have if we're running from 90 to 180, because it would be the same, that would be the same values but going backwards. All right, so we're just reflecting them. We're reflecting it into negative area and we're repeating it. Basically it was going down, now it's going up here. So what we have to understand clearly is what is happening between 0 and 90. This is what we're going to do now. So we are having values between 0 and 90 from the sine curve. So we just increase, we zoom um, our area and our picture, and then we're trying to understand. We know it's 1 at 90 degrees and it's 0 at 0. What's happening in between? Well, let's see what is happening at maybe 45 degrees, because if that would be a straight line like this, then at 45 degrees we must be exactly in the middle at 0.5. Is that the case? Well, obviously it's not, and we want to prove it. So let's do it. What are we doing? Well, once again, unit circle. There you go. Got it here. And we are taking 45 degrees. We're here, 45. All right, so it's a right angle triangle. This value is the x value, then we have the y value, and since it's 90 degree right here and this angle is 45, this one must be 45 again. So our triangle is isosceles. That means we have equal side lengths, and that means that the cosine of 45 degrees, this is the x value, is the same as the y value, which is the sine of 45 degrees. Well, that's nice. Don't forget we are in a unit circle, so that means that the cosine squared of 45 plus, well, 45 degrees, not squared, plus the cosine squared again, I can substitute kind of sine over cosine because they're equal, is equal to 1. So twice the cosine squared of 45 degrees is 1. Dividing by 2, having cosine squared 45 degrees equal to a half. I'm taking a square root. I'm basically having plus or minus, but I'm working with plus only because I have positive values here. I'm not talking about the negative values in this case. So the cosine of 45 degrees is equal to the sine of 45 degrees. And this is square root out of 1 divided by 2. If you apply the power rules, you can write it as square root of 1 divided by square root of 2, which is 1 divided by square root of 2. And sometimes you see maybe at the school or in the universities, we want to have the denominator being rational, so we're just expanding this fraction. We're multiplying times 1, which we are rewriting as square root of 2 divided by square root of 2, and the result is square root of 2 divided by 2. So that's the sine and the cosine at 45 degrees. All right, so it's approximately 0.7, it's not 0.5. That means we're slightly higher than the middle, so we're somewhere here. Let's say it's approximately 0.5 would be here, and this is 0.7 or something. All right, let's move on. Before we move on, let's see maybe the following idea. If we have a right angle triangle, we have A, we have B, and we have C here. This is 90 degrees. We have angle of beta. This is alpha. And, well, what is the sine of alpha? The sine of alpha, this is equal to A divided by the longest, which is C. The sine of beta is B opposite divided by the longest C. And now if we're talking about cosine of alpha, this is alpha is the adjacent, which is B divided by C, and the cosine of beta is A divided by C. Now you see, for example, this value is equal to this one. What it means is the sine of alpha is equal to cosine of beta, right? But at the same time, you see that we have the sum of angle in a triangle equals to 180 degrees. One of them, in this case, is 90, so alpha plus beta must give you 90. That means beta is 90 minus alpha. So sine of alpha is cosine of beta, but beta can be replaced by 90 minus alpha, so which is very handy for our purposes. We have the cosine of 90 degrees minus alpha here, which is actually nice, right? So how would it help us to compute further values? Well, let's see. Now let's take the case where the angle is 60. So the angle is 60 degrees. That means we have 60 here. And let's consider such a triangle, okay? So we are in a unit circle still. That's the story here. And let's put a height here. Well, kind of Picasso working this time, but that's all right. You must get the idea. Oh, sorry. I'm not that famous as Picasso, and I don't want to be a famous painter. Just want to show you some mathematics. So that's slightly better maybe. I should be getting in the middle, which I'm not doing, but it's all right. So this value should be 0.5. Why is that the case? Well, this is the same radius we have here. So that means those two lengths must be equal 1. They are because of the construction. And we have the angle of 60 degrees. So for those two angles, we have remaining 120 left, and they must be equal because of the two radii to be equal to each other. So we have an isosceles triangle once again. And that means we have 120 degrees for two angles that must be equal. So each angle is 60 degrees. And this one is 60 as well. So it's not even an isosceles triangle. It's even further, it's an equilateral triangle. So that means all the side lengths are equal. And one of the nicest properties of the isosceles triangles actually, but also equilateral triangles, is that we're getting exactly in the middle if we are putting a height. So the middle of one is 0.5. So this value is 0.5. And if we're considering this triangle, this x value, 0.5, is exactly the cosine of 60, which is nice to have. Why? Well, let's go back to the formula. Cosine of 60 is equal to the sine of 90 minus 60 is equal to the sine of 30, which is 0.5. Isn't that nice? Well, that's pretty nice. That's why we're doing this. And what about sine of 60? Let me come back and let me show you here on the big graph what's going on. So we're having at 30 degrees the value of 0.5, which is here. Now you see maybe already a kind of wave structure. And let us do the last computation in order to completely understand or roughly understand the behavior of the sine curve between 0 and 90. We just consider once again this right angle triangle, and we know this is 1, this is 0.5, let's call it y. So y squared plus 0.5 squared is equal to 1 squared, which is 1. So y squared is equal to 1 minus 0.25. It's 3/4. And if we take a square root, once again, we have two values, plus or minus. We're talking about positive values, so y is equal to square root out of 3/4, which is square root out of 3 divided by 2, which is approximately 0.866, if I remember it correctly. I don't want to remember these values, and I'm not... that's why I'm proving you. I don't want you to remember it either, so I think it's better to understand how they are appearing in our tables. So this is once again a bit higher than the previous value at 45. So we are at 60 degrees. We are somewhere here. And now you see the shape of the curve would be like that. And this is exactly where the wave is coming from. And now this is the behavior between 0 and 90, like this, 90 to 180, like that, because we discussed it's reflecting, like going backwards. Now we're doing the same shape movement, but we're going into the negative area and we are reflecting it as well. And from that point on, we would be repeating it over and over again. Okay, and we could have had something previously going on. So it's not clear it's pretty clear it must be the same. All right, so this is just an introduction to trigonometry playlist, and I hope it helps somebody from my visitors and YouTube watchers to understand what's going on. See you guys in the next video. All the best. Bye bye.